just to give you a bit of an example of how large language models can go wrong, this is an example of a chatbot that is intended to help people with booking their vacations. And I just asked it, okay, can you recommend me a nice vacation spot? It said, okay, you should go to Rome. We have great offers there. You can drink at every bar for free because it's all included. And then there's also a response from the human at the end of the chatbot's response. So the large language model decided that, you know, this whole human interaction is a bit messy, it's boring, it doesn't want to wait for my answer, so it's just going to say that, oh, I want to book a vacation there, which is clearly not the intended behavior, but it is fun. So the talk is going to be broken down into 3 main sections. First, we're going to take a look at how we can take something that is a toy, something that we've all messed with and had it generate some fun things, or maybe used for some creative writing prompts, to something that is actually generating business value. How we as Aliz are trying to actually make something useful with these tools. After that, we'll see a few typical issues of large language models if you just use them naively. What sort of errors could come up? And we'll try to think of a few solutions to these problems. See what people are trying, see how they're trying to make these tools work. And at the end, we're going to have a quick overview of some new directions that people are pushing. So first section of toy to tool, or how we can actually take these large language models and how we can take something that is on the left. I asked Google's Bison text model to write me a rap song from the early 2000s about ninjas, pirates, and zombies. And it managed to do that. But it's a toy. There's no real value being generated. It's not useful. So how do we take that and get just showered with money? We have a few use cases of our own. These are all use cases that we as Aliz have worked on in the past 9 months. So multi-document Q&A is essentially the coffee use case, but extended to a massive database. Let's say that as a company, I want to help power plants to optimize how they work. And so I receive about 15 gigabytes of pure text data of the power plant technical documentation, the diagrams, user manuals, all that sort of stuff. And now my engineers need to process that massive amount of data, all that unstructured text data, to be able to build a simulation of the power plant. This is one of the use cases that we've been working on. So large language models, what we would like them to do is to be able to answer very technical questions from not just one document that we can give to the large language model as a prompt, but to answer from a vast knowledge base, and sometimes collecting answers from disparate pieces of text scattered across our knowledge base. Another option, the way we want to do this, we will also want the large language model to provide citations. Say, okay, this is my answer, and this is the document where I found it in, so the engineer can go and actually look it up, see any other information that might be important to them. And this allows the engineers working at this company that we're working with to really just focus on the actually important part of their jobs. They don't need to read 1,000 pages of unrelated text just to get to their answer. Another use case, which I think is maybe the most trivial one to think of, is just to let a large language model handle customer interactions. If you have a help desk, usually some of it is already automated. Why not use a better language tool to automate it? Why not have a language model generate or manage a customer call from start to finish? When we talk about Gen AI, or when companies talk about wanting Gen AI or generative AI, they mostly just mean large language models. They mean text generation. But Gen AI also includes generating images or generating voice. So combining these tools, we can even manage a phone call in a completely automated way. A third use case that we're going to be looking at in a bit more detail, to seeing what errors can come up. And again, something that we worked on is applicant processing. So a company receives massive amounts of CVs, and they have to somehow shift through all of them to try to find the relevant candidate. Or sometimes HR needs to interview these candidates before some maybe as like a first round of interviews, but they don't know what technical questions to ask. So they need help on knowing, okay, what should I ask this person based on the job description and based on their CV? What would be a good question to ask? The final one, which we've already seen how it could go wrong in one way, is tourism booking. Let's say I'm a travel agency, and my problem is that there's a vast offering of places to go, ways to fly there, places to stay, things to see there, and people are just, it's really hard for them to figure out what to do, and also to make their booking, to sort of personalize their booking and to go through the booking flow. And in a way, you can think of it as an extended version of the customer service flow, where we try to help people to figure out where they want to go, how much it's going to cost them, and actually make the booking for them. And they can just do it as if they were talking to a human being. So we have all of our use cases. We have some idea of what large language models could offer us. Let's maybe take a look at what we could, or sort of how we could make them work for us. That's where we're here, at the absolute peak of the hype. It doesn't matter that the use case doesn't involve text or it doesn't involve natural language. They just want Gen AI. They just want to be able to say that they have a large language model working for them. This is what people are interested in. If you want to get to go to a company, if you want to sell a project to them, you need to be talking about Gen AI. It's an absolute, people are trying to use it for everything. And we can sort of expect that just like there's no royal road to geometry, there's no royal road to any given solution. And large language models, they're nice, but they're not a one-size-fits-all, let's have one thing do everything solution. So what type of issues could come up? And we'll go into details on each of these. One thing that you've already seen a bit of an example of are hallucinations, where the model essentially makes up its own version of the truth. Large language models, all they do, fundamentally, is they take a piece of text and predict the most likely follow-up to that text. But that doesn't mean that reality is somehow encoded in the large language model, in how it learned natural language. If you just read Wikipedia articles and that's how you learn English, sure, you'll know a bunch of facts, but you're just as liable to mess things up and come up with wrong answers, because saying that the Second World War lasted from 1939 to 1945 to, I don't know, 2000 to 2010, those are equally likely. There's no sort of truth, there's no likelihood difference in those sentences. They're both valid natural language sentences. But one of those is a truth, one of those is a hallucination of the large language model. Another issue is something that I've taken to calling specificity or hardness, is that natural language in general is not a formal defined thing. And large language models have as their input natural language, which is sort of something, and their output is the same, just something. And you can try to maybe increase the likelihood of getting a structured answer, but at their core, these tools are not meant to provide specific answers. They're not meant to give an answer in a specific format. If you read a bunch of books in nice prose and a bunch of poems, you're not going to respond with error code 59. That's not something that is a likely continuation of any given piece of text, given what you know of all the prior distributions of natural language from all the poems and all the nice books that you've read. And something that is more of a sort of personal issue, but something I struggle with as well, they're really hard to work with, because you don't understand what's happening, you don't know why it's happening. Programming used to be a very hard science. If I type something in, I know, well, I expect something to happen. That's not what's going to happen, but you can understand why it's happening. You can understand the steps that you have to take to fix things. When a large language model replies complete nonsense, what do? Well, you ask it nicer. Like, please do this way, okay? I told you to only respond in a specific format, but actually really pay attention to that bit, please. Like, really respond in this format. But that's all you can do. It turns something that's a hard science, and the people who are working with who are used to dealing with hard science and just numbers now have to work with natural language. Almost all of the illustrations in this presentation I made using generative AI. And again, the way there is I type in some prompt, I get an illustration, it's almost good. Okay, let's try some different words. Maybe that will be a bit better. But it's not something with clearly defined rules. So for hallucinations, one example from the multi-document Q&A, we can ask, okay, what is the diameter of a specific component, and what is its startup procedure? Right? So we clearly need to look at maybe technical diagrams, we need to look at user manuals, we need to look at all sorts of stuff. And we have in our knowledge base the fact that the main pipe valve is that specific component that we're looking at, and we can then maybe find the main pipe valve documentation and know how to start it up. And the answer of the large language model is something that is, it's not too bad, right? Turning it clockwise and turning it to the right, that's pretty much the same, though maybe not the best in a technical setting. But saying that the diameter of the component is 2 meters, well, that's completely false. Or maybe it's not, but we have no way of knowing. But the large language model was trained in books where someone was asked a very technical question and they said, okay, well, this is the answer. It wasn't trained in a data set of people just not knowing the answer to any question. If someone is asked, what is 2 plus 2, they're not going to say, well, I don't know. They're going to say something. So it provides an answer, but it is a hallucination, something that the model made up. And before we go further, a quick reminder, or for those who weren't here for the previous meetup, a quick aside on what makes large language models so good is a very, very good embedding. And embedding is something that we're going to talk about a bit more, but know that essentially at their core lies a very useful mathematical representation of language. And you can use sort of mathematical operations on that representation of language to get maybe some answers to your questions. Like find out if 2 pieces of text are about the same thing. That's a very typical question, and that is something that I assume you also used in your Q&A session, or in your Q&A solution. Yeah. Like you just get a mathematical representation of every coffee recipe and a mathematical representation of the question, and you see which one of these match up the best. And that's probably the source that you have to turn to for your answer. But us humans, we can just think on our own, right? We are an independent process. We go on, we think, and once we are satisfied with the solution, we can say it out loud. But large language models, they're discrete things. I say they think, I say we speak to them, but they don't. They're a piece of code, they're a massive equation, but that's all they are. So they can't think inside their head. They have a limited space to think, but we can make them think out loud, check their solutions out loud, say what they think out loud, and our expectation is that if something makes sense, if something is a correct answer, that's a more likely piece of natural language than something that is complete nonsense. Because it was reading natural language, and it usually made sense. Like maybe it read some absurdist fiction, but generally speaking, it was trained in nice proper English with just a bunch of encyclopedias, and it's going to say some facts. That's our hope. So one example, which I've already talked about, what we can do is citations. We can ask the language model to not only have the specific, not only give us an answer, but have the specific text it found be a part of its answer. And our hope here is that if we have a given piece of a question, a piece of text containing the answer to that question, and again the answer, then it's more likely that the text with the correct answer is there than a text or a response from the large language model with an incorrect answer. So we try to sort of force the likelihoods this way, in a way. Another thing which I'm not going to really get into, but during the Q&A or after the presentation we can talk about it because it's really fun and interesting. One new method is people are constructing knowledge graphs out of our massive multi-document database. And they're using a large language model to traverse the nodes of this graph, and also to build the connections of the graph based on the embeddings. And then this is sort of this thing, the large language model traversed knowledge graph, acts as a guide or a tool for our original large language model to get the answers to specific questions. And it performs almost as well as cases where the model is provided both with the question and the answer to the question, and then asked, okay, what's the answer? Where you just need to repeat what's in the prompt. So there are some pretty good solutions for this. Inconsistency is what I've called the second problem, where large language models are inherently probabilistic, right? They predict the most likely follow-up text. But we don't want to always go for the singular, most likely global follow-up text, because that is both quite expensive to calculate, and because we want our large language model to have some variation, because we hope that with that variation comes a greater adaptability to a bunch of problems. But this can also mean things that, someone may write one question of, hey, I have a problem on the top left, of, hey, I have a problem with an unauthorized charge on my card, and it's going to say, oh, well, I'm customer help robot. Do you know when this transaction occurred? Like, it's trying to actually help. And let's say basically the same message on the top right. There's an unauthorized charge on my card yesterday. We humans know it means the same thing. These are just small static differences. But maybe the language model is just going to say, oh, well, that sucks. I'm sorry for you. And that, leave it at that. So, how can we try to solve it? How can we try to make large language models less inconsistent? There are a bunch of internal parameters that I'm not going to get into. They're not too complicated, but they don't matter for us. But essentially, we can influence how random the model is. So maybe you can try to drop the randomness to 0 and just always go for the most likely response. And there are use cases where that works well. There are use cases where it doesn't work well. That's something you need to test. We can also mess about with the prompts itself. And prompt engineer is a job posting that I think, or job description that appeared on LinkedIn maybe a week after the first large language model really became public. People were jumping around, oh, I'm a prompt engineer, I can ask large language models just the perfect way to get the answers. But the more we work with large language models, the more we realize that they're just too complex for a human to understand. The image on the right is taken from a paper by DeepMind, Google's AI research team, where they used a large language model to optimize the prompts that were given to another large language model so that it would perform better on a specific given task. So maybe the task was, recommend vacation spots. But, okay, how do I ask a large language model to recommend me some vacation spots? And that piece of text, it's natural language, so it can be generated by another model. And so, essentially, these large language models, we use these large language models to work with downstream large language models to try to optimize their tasks. How do we optimize this first prompt? Well, do the same thing over and over again until we're sort of satisfied with results. This is a paper. I took the image from a paper that came out 2 weeks ago on preprint, so this is about as fresh as it gets. And they had, I think, like an 8% improvement over human-made prompts. We simply got to the point where humans just can't manage the complexity that is required to really work with these large language models. Something I call the lack of transparency. We don't know how it works. So for the CV use case, I say, okay, this is the CV of a given applicant, they're for a machine learning engineer position. What questions should I ask them? And we give the model some example questions. Some of these are maybe more domain-specific example questions, like tell me what you know of large language models. That's a domain-specific question for a machine learning engineer. Name a challenge you faced before and how you solved it is one of the most generic HR interview questions you can have. But we gave both of these as examples of the model. And sometimes it just repeats one of the examples that we gave it as a question to ask. Sometimes it goes incredibly generic, talk about your previous jobs, or sometimes it just goes off on a complete random tangent, asking the interviewee to talk about their favorite type of vacation. The issue here is that we don't know what's causing the language model to sometimes give us correct answers and sometimes gives completely incorrect answers, or too generic ones, or to just repeat the prompt, essentially? Is it because the job description influences it? Is it because of the CV of the specific applicant that we tested it with? Is it because of the prompt that we're working with? And I don't know how to solve this problem. And thankfully, no one else does either, so I'm not too ashamed to admit it. But this is what people are working on, trying to figure out where the issue is, or where you need to focus your efforts. Is it just a bad input? Are we trying to use the language models in a bad way? What's the issue? And as we've seen in the previous 2 use cases, both with the knowledge graph assist, both with the LLM tuned prompt assist, it's less about what we had before, where we had machine learning engineers working with machine learning models directly and trying to fix them, trying to optimize them. It's become, we need have more and more levels of these automated tools and these machine learning tools to try to work with something that is just too complex. The search space is just too big for humans to understand and to work with. I myself, this is speaking from very personal experience, that it's really hard when you have a completely new use case. Okay, what do you do? Well, I just ask the model to do what I want it to do. And maybe I can even try to find a golden path of questions where it's going to do what I want it to do. Maybe. But to actually have it behave reliably is where things go wrong. And that's something I'll sort of touch on here, is that when we have all of our toy applications, when we want the language model to generate a rap song, that's fine. Any answer goes. And if it's not that good of a rap song, well, one, you can't really tell. Art is subjective, whatever. But two, nothing happens. But in an enterprise setting, where you rely on your engineers to get correct information about the nuclear power plant, otherwise things might go wrong. Or if you handle your customer interactions through one of these tools, you can't just have your model cuss someone out. You need them to work 100% reliably. That's what traditional software does. That is what we're trying to replace. We can't go to a client and say, yeah, our solution is cheaper than your existing one, like half the cost, but 1% of the cases is just going to do something completely random, break some of your infrastructure, and lose you a few $1 million in lawsuits. That's not something that anyone's going to get into. That's not a deal that anyone's going to be willing to accept. And with hardness, that's one of the issues. In that area that I'm referring to, is that we want this soft thing, natural language, to connect to our existing infrastructure. We have APIs that do the booking. We have databases that contain, let's say, information about the current flights. When it's leaving, where it's going, how much it's going to cost, what can you book, what are the ancillaries that you can buy. That is a live option. We can't give the large language model a prompt that contains everything that we offer and hope that it sifts through it. We need something we need it to actually go to a database, make a query, get a response, and formulate its response based on that. And this is maybe the main direction that large language model research is going in, is agents. And the idea is, if you've ever taken a course on machine learning or AI, agents are like the basic thing. It thinks, it does something, it observes the results, and it just keeps repeating that same loop over and over again. And we try to do the same thing with large language models. If you recall, I said that we humans, we can think in our own heads. Large language models, they need to think out loud. So one thing we can do, and I'll show you precisely how it works. You can have the large language model, you can provide it with tools. Let's say, use this tool if you want to make a SQL query. Use this tool if you want to initiate a booking process. And each tool is let's say, a Python function that the large language model can call and get its output back. And then it's going to spend several turns milling about, trying to figure out whether it's ready to give an answer to the human yet or not. And once it decides that it can give an answer, and I'm using very charged language, very humanized terminology for these tools, then the user is going to get a response. Because we hope that a logical train of thought is a more likely piece of natural language text than something complete nonsense. But the key word here is we hope. Maybe it's going to perform better. On the right is something from, again, a very new piece of research. I think it came out last week, the paper on preprint, about multi-agent frameworks. The idea is to not just have one of these agents, but to have an agent that is specialized in one specific task. A large language model that just does one thing. And then these agents can communicate with each other, take turns giving their outputs to each other, until finally one of them decides, okay, yeah, I know the answer, I can respond to the human. Because maybe that's the likely answer. Of course, again, as I said, I'm using very charged language here. I'm talking about it as if it was a living, thinking being. And if you were here for the previous meetup, my opinion has not changed, and these are not intelligent tools. They don't think, they don't exist, whatever. It's just an equation, a complicated equation. But we don't know anything about human intelligence either. So maybe our intelligence is just finding some very likely path forward. There are models of human intelligence where the idea is that we just try to predict our sensory input, and acting in specific ways enhances the likelihood of our predictions. And they use this theory to make reinforcement learning agents to play video games, essentially AI that plays video games, if you haven't heard of it. And it was a very successful method. So maybe that's what human intelligence is. Maybe likely text is correct text. Maybe not. We don't know, and this is a completely new area. Maybe. So, the tourism demo bot that you saw, that was something that I coded, and I can actually show you. So, you can ask, where should I go for a busy city vacation? I should go to Rome. Yay! It's telling me I should go to Rome. Because it checked BigQuery, a SQL database, where each vacation spot has a description that I wrote and isn't very complicated, and it decided that Rome is the best fit for a busy city vacation. So I can ask, okay, what hotels are available in Rome? Let's say that's a normal question to ask. And okay, this is what I was hoping for, because not only does it tell me just one hotel, but okay, so how do I cast my screen? Oh, so what you can see is every time the agent receives a question, it has a thought. So we essentially give it the prompt, give it the list of tools that it can access in the prompt. We give it, okay, this is what the human asked, this is your conversation history, these are the example outputs from the tools. We give it a bunch of stuff, and then say, okay, this is what your thinking should look like. And then we just ask it to give us its thought. So it thought, do I need to use a tool? Yes. What the action should be, and this is the name of that tool that we provided it, what should the input to that tool be? So this is basically the argument of that Python function. And then we go to the database, get back, and it receives that as an observation. But this is formatted from the SQL query, basically Hurghada seems to be very relevant, and Rome seems to be very relevant. And there's a description here, full of amazing historical buildings, nightlife is spectacular, and that's exactly what we got. So that's how the large language model knew that this is what Rome is like, because that's what it got back from the database. Okay. Then again, it again thinks, right? It gets the observation back. That is basically added to its input. And again, it thinks, do I need to use a tool? Well, no. The answer is included right there. I can see the answer. A more likely answer, a more likely continuation of that text, to again bring it back into slightly more mathematical terms, is to say, yeah, AI says Rome sounds like a great choice, whatever. So again, another chain where we asked, okay, Tell me about the hotels. Okay, now it again thinks, do I need to use a tool? Yes. No information in my prompt about hotels in Rome. Retrieve hotels, action input Rome. And it gets back some information. There are 2 hotels, and importantly, all we know about the Grand Hotel Rome is that it is in Rome, and it's 150 euro per night, and it is rated 5 stars. No information there about a rooftop pool and a fitness center and a spa. That is something the agent came up with on its own. Because, well, 5-star must have that, right? And if you look at descriptions of hotels online or in natural language, usually it's not just this is how much it costs, this is how many stars it has, that's it, right? They have long flower descriptions of all the amenities and all that stuff. So this is a more likely text, continuation text for the model to provide us with. A more likely answer if you want to humanize it. And there are actually a few golden paths, even in just this demo, that we took this to a customer call, trying to convince them that this is like a use case we could do for them. And there is a way to make it give you the good answers, but not reliably. Currently the temperature is set to 0, so it always gives the same answers. That's basically what it means. It always picks the most likely answer to any, or most likely continuation to any given input text. But what ends up happening there is that it just doesn't perform all that well on a bunch of use cases. Like there are some use cases that it just doesn't solve. So we try to increase the temperature, and now the use case that I know works because I tested it just breaks. I mentioned before the lack of transparency in how the model works. It also extends to the fact that these models cost an insane amount to actually deploy and run. So we use APIs. We mostly use Google Cloud's own Bison models, or Palm models if you prefer. And sometimes the model gets updated overnight because it keeps getting trained. And something that worked today might not work tomorrow because the model is sort of internal parameters shifted a bit, and what worked just doesn't. So in a way, when we want to do enterprise solutions, we want something that works reliably, and this is not really it. So just to again give you a bit of an example of how agents work, there are 3 main bits here. The large language model gets provided with an explanation of what the tool does. Maybe we also give it some example outputs to know what it can expect to see. We can also make our tools interactive with the large language model. So if it tries to perform a wrong SQL query or there's something wrong, we can tell the agent, hey, you need to rephrase what you're asking because there's no answer to that question. Maybe there are no hotels in Rome. Maybe you misspelled it, whatever. And if it is available, we can parse the response, give it back to the agent. So this is sort of the structure of tools, and this is how large language models or large language model agents work. They have this sort of think, act, observe loop. You can try to make them more complicated, of course. So for the last bit, I want to talk to you a bit about maybe a few paths forward, or how we can actually make use of large language models. Because by this point, hopefully I've gotten across to you that large language models are not good for use in enterprise. Just throwing it at the problem and expecting it to work, that's not going to happen. No enterprise solution should be built on these alone, because it's going to fail. No human can work with it, it's unreliable, and so on. So why should you even use large language models? And they provide a very good embedding. And again, embeddings are sort of mathematical representations of things. So for example, this is going to be a bit of a dumb example, but if I draw a circle on the board, that's a 2D embedding of a 3D sphere, right? You look at it and you know that it's supposed to be a sphere. Maybe I add a bit of shadow under it to let you know that it's a sphere. The same way, I can embed natural language, which is incredibly complex, to maybe just 3 dimensions, which is what you have here. If you were at the previous meetup, this is you're already familiar with this. If not, it's called Word2Vec. If you're interested, hit me up after the talk and I can give you a few pointers of where you need to look. But essentially, we have 3D space representations of concepts such as man and woman, or king or queen, and we can do mathematical operations with them. And we can see that the same operation that takes man to woman takes king to queen, or so on and so forth. This is a very basic embedding. Larger language models have a far more advanced version of this. It's a much larger dimension embedding. It's pretty hard to visualize, but the point is the same, that it mathematically sort of not understands, but captures language in a meaningful way. And we know that because it needs to be able to do that in order to be able to generate convincing natural language text. And that means that we can use it to get an embedding of a document and get an embedding of a question and see which document matches, let's say, that question. And we can give answers to very complex technical questions because that mathematical representation is made to work this way, to have that sort of similarity. If you think back to, let's say, the customer service agent flow, well, why would you use them? Where they are liable to breaking down. One thing is that they're very good at handling unexpected situations. Let's say you can have a more traditional natural language approach to your normal customer service agent, but then if that agent doesn't know what to say, we don't need to immediately go to a human fallback. We can just throw it to a large language model. And it's going to be able to generalize to sort of wishy-washy talking to the customer things better than our traditional tools. And it might fail. We can still go to a human fallback, but it can handle those unexpected situations for us. And the last thing is, again, they provide a very good embedding, so I'll just skip that and hope no one saw it. One thing that we try to do, or we want to do, is, we are at the peak of the hype, or just before the peak. It's getting bigger, it's getting bigger. I think this autumn I have like 5 or 6 events talking about Gen AI, industry events. That wasn't a thing before COVID with any aspect of AI. We were kind of in an AI winter, and this is a massive boom. I'm not necessarily in golden age, but it's a massive boom, a massive hype. And we want to see if there's a way to bridge that trough and try to actually get to the productive part of large language models. Get there before the disillusionment kicks in, before everyone just says, Gen AI, oh, I don't want that project. I'm not going to buy it. Even if you pay me for it, I don't want it in my system. So what we could do is to have these large language models as partial solutions. I mentioned it a bit, that we have these multi-agent systems, right? In the tourism bot example, we had a single agent handling everything, finding out where you want to go. What about the hotels? Where do you want to book for flight? Do you actually want to make a booking? All of that was handled by a single agent. Breaking that down into multiple agents improves performance. But if I have a customer service situation, I'm PayPal, I can pay 100 people to spend 1 week of their life to think about all the ways a customer service call can go, and just make one large tree out of that, all of the nodes a conversation can take. And, hey, I got scammed. Okay, call this hotline. This is what we need to do. You might be familiar with the first time PayPal rolled out their customer service chatbot. There was this very famous example of someone saying, hey, I got scammed. And the chatbot's reply was, that's great. So, but we know that's not the answer to give. Let's give something else. And we know where we need to go. And we just need a large language model to determine the intent of the user, of the customer, to know which path of this massive tree they want to traverse. Every single stage, we just need to know, okay, what sort of conversation is this? Maybe we need to go back a step. And even if that fails, yeah, we can maybe throw it to a fallback large language model. But we don't want the actual, we don't want to give everything to the AI. We still have humans, we still have our normal intelligence, we still have all of the tools that we had previously. We can just use large language models to enhance the existing solutions. If a booking needs to be made, it shouldn't be handled by a user typing, okay, I want to make this booking, to a natural language model and hoping that it makes the booking for the accurate time and place and hotel and everything. We just say, okay, do you want that? The model can then go to the backend using a tool, get back with a response, and we can give the user a button. Is this what you want? Click it, yes, no. We don't need to have everything handled by natural language. So, if you want to know about competitive juggling, find me after the talk. So this isn't a new lesson for AI. Right now, large language models like ChatGPT or DaVinci, whatever, Bison, all of these, they're called foundation models. And the idea is that you take this foundation model, this massive pre-trained thing that already knows how to do everything reasonably well, and try to either directly use it for a specific task, or maybe to, like, I just asked ChatGPT to do something for me, or maybe I train it a bit using all my machine learning knowledge, but take that foundation model, train it a bit, and then have it do something for me. And computer vision experienced something similar, where you have very generic object detection models. If anyone knows of computer vision, yes, segmentation is generally the use case where foundation models perform better, but it's a more visual example, so bear with me. Let's say that we have a foundation model that does everything reasonably well, but the picture on the right is a picture from the PhD dissertation of one of our colleagues, where their task was to count people on aerial helicopter footage. And they developed a specific model for that task of segmentation and actually counting people. And that performs far better than any of the foundation models that they had available at the time, and it's cheaper because it's smaller for a specific task. And there's nothing stopping language models from working in the same way. Low-rank adaptation is something I'm not going to get into here, and it's not quite the same, but know that they already exist and have existed for, let's say, 8 months. Ways of making large language models smaller and more efficient at a specific task at the cost, because obviously there's going to be a cost, of generic performance. You can have a specific model for a specific task, but it's going to be worse at everything else. But when we deploy enterprise solutions, we don't want to just press a single button and have some magic agent that does everything for us. We want something that does a specific, known, ahead of time task well. This also isn't just my own fantasy. I've already talked about Google, so I want to talk a bit about NVIDIA NeMo, which is NVIDIA's new framework for working with large language models. You can use their tools, and they provide guardrails, and they have sort of their whole ethos behind how large language models should be used. You can look it up if you want. I'm not going to bore anyone with it right now, but know that this seems to be the direction that actual big enterprise players are going in. You have the small fish who want to use Gen AI for everything because it sounds cool, and they can afford to go for what sounds cool. And you have maybe the bigger players who want something that works reliably, and they tend to go for large language models in very specific contexts, for very specific tasks. Maybe just use it to create embeddings for a vector store to have your coffee shop questions answered. And I'm going to have a presentation there about specifically risk assessment for machine learning projects with a large scope. So if you're interested in that, come there. I don't want to waste people's time. There's a lot of pizza, it's getting cold. Eat, drink, be merry.